So just one final video to review how to combine functions. So in this section you're given this question you're given four different functions: f of x, a quadratic function; g of x, a linear function; h of x, a radical function; and I of x, a logarithmic function. And you're asked to combine them in various ways down here in parts A through D. Multiply them, subtract them, divide them, add them. Okay, so there's one of each. What I'd like to do, and it wants the domain, it just doesn't want just the equation of the new combined function, but it wants the domain. So I would suggest coming up with the domain of each of these first. So I've written down f of x, g of x, h of x, and I of x. Did a little work with f of x, simplified it a little bit. Okay, I expanded this bracket x plus 2 squared to get x squared plus 4x plus 4 minus 3. Combined the positive 4 and the negative 3 to get a positive 1. And that is another way of writing this equation. But let's look at the domain for all of these functions. The domain of f of x, since it is a polynomial function, would just be x such that x belongs to the real numbers. Or from negative infinity to positive infinity. Same thing for this linear function. Okay, it's a straight line. That's what that curve would look like. It's a degree 1. So the domain of that would also be x such that x belongs to the real numbers. Or from negative infinity to positive infinity in interval notation. The radical function, remember to find the domain, we want to take the radicand x plus 5 and say that it has to be greater than or equal to 0. Okay, you cannot take the square root of a negative. You can take the square root of a 0, though. So I end up with x is greater than or equal to negative 5, and my domain becomes just that, x such that x is greater than or equal to negative 5, x belongs to the real numbers, or I would have negative 5 to infinity in interval notation. Finally, with logarithmic function, similar to radical functions, you cannot take the logarithm of a negative. It wouldn't matter what this base is. Okay, in this case, it's a base of 10. It's a common logarithm. But if it was a natural logarithm, an ln function with a base of Euler's constant e, right, or if it was a base of 2, you cannot raise a base of 10 or e or 2 to anything and get a negative answer. So this cannot be negative. The argument cannot be negative. So what I say there is x has to be greater than, x minus 3 has to be greater than 0. It can't be 0 actually either. So x minus 3 has to be greater than 0. Okay, like I said, 10 to the power of nothing would give you 0. That's not possible. So I would get x is greater than 3. So the domain becomes x such that x is greater than 3, x belongs to the real numbers, or from 3 to infinity using interval notation. Right, so it's helpful to know the domain of all of the original functions, because when we combine them, the domain of the combined function will be whatever's common to the original two. So part A wants us to multiply f of x by g of x. So I've taken f of x, x squared plus 4x plus 1, and g of x, 3x plus 1. So it's this guy and this guy, and I'm going to combine them by multiplying them. Well, when I multiply them, I've got a trinomial times a binomial. Should give me 6 terms. That would give me 3x cubed. That would give me 1x squared, or x squared. That's going to give me 12x squared. That's going to give me 4x. So everything in this bracket gets multiplied by everything in the second bracket. That gives me a 3x. That gives me a 1. When I combine my like terms, or I group my like terms, I have this 3x cubed all on its own. I've got an x squared and a 12x squared for a 13x squared. I've got a 4x a 4x and a 3x for 7x, and I've got this plus 1. So there's the 13x squared, there's the 7x. That's how I got it. That is the equation of the combined function. The domain of that would be whatever's common to the original two. Well, the domain of f of x was x belongs to the real numbers. The domain of g at x was x belongs to the real numbers. So the domain of the combined function is going to be the same thing, x such that x belongs to the real numbers, or from negative infinity to positive infinity. Okay, easy one to start. Next up, I've got h at x minus g at x. Well, h at x is the radical function. G at x is that linear function again. So h minus g is going to equal radical x plus 5. And all I'm going to do here is distribute the negative over both of these terms. So it becomes negative 3x minus 1. Now, remember the domain of h at x was greater than or equal to negative 5. And the domain of this was x belongs to the real numbers. So the combined domain, so it's this one and this one, what numbers are on both curves, or what x values would exist on both curves? And it's just these ones from negative 5 to infinity. All right, this one's got all the x values. This one has just the x values from negative 5 to infinity, so we got to go with this one, because the x values between negative infinity and negative 5 aren't on this one. So the combined domain would be x such that x is greater than or equal to negative 5, x belongs to the real numbers, or from negative 5 to infinity. All right, f of x divided by h of x. F of x was the quadratic function. H at x was the radical function. So, same situation. If I look at the domain of f of x, it's x belongs to the real numbers. The domain of h at x is greater than or equal to negative 5. Okay, so what's common to both of those? It's the same as the last one. It would be these numbers right here. These x values. X is greater than or equal to negative 5. So the domain is going to look like this. X such that x is greater than or equal to negative 5. X belongs to the real numbers. However, remember division by 0. So when you're dividing, this is the extra little step. Division by 0 is impossible. So I would say radical x plus 5 cannot equal 0. Square both sides. X plus 5 cannot equal 0. Subtract 5 from both sides, and we could say x cannot equal negative 5. Well, rather than adding a cannot equal negative 5 to this, all right, I can make that happen by saying, or just simply removing this right here. Now that means x is only greater than negative 5. It cannot equal negative 5. Okay, so there is the domain. And finally, f of x and I of x. All right, I could have used the x squared plus 4x plus 1, or in this case, so I would accept either of these, x squared plus 4x plus 1. That's that expanded. All right. You go back up here, x squared plus 4x plus 1, there it is. Now remember, that has a domain, x belongs to the real numbers. The domain of I at x was x was greater than 3. So what's common to both of those? If you think of a number line, this would be shaded from left to right, from negative infinity to a positive infinity. This number line, these x values would be from 3 to infinity. Well, what x values are on both number lines? What's common to both number lines? Just these ones. Okay? Everything from negative infinity to positive 3 is not on this curve. And remember, this would have like an open dot right there if I was shading that number line because it cannot equal 3. So for the domain of this combined function, I will just say that x such that x is greater than 3, x belongs to the real numbers. In interval notation, that would go from 3 to infinity. Round brackets because it cannot equal 3. Okay? And it obviously cannot obtain infinity. So these are my combined functions. And the domain is in red underneath. And in a nutshell, that covers the last 2 sections, all right, or the last 2 videos we looked at. And you can try the review sheet.